So we are recording Chapter 19 lecture. So this is an introduction to database programming. I always kind of personally revitalize myself a little bit when I get to this chapter. You know, it's been a grind, to get this far. You guys have worked hard in this class. And this is a little bit of a rejuvenating point for me because it's flat out different than everything we've been doing so far. And in fact, this is a whole different career opportunity, which is working with databases. Specifically, there are database administrators. I mean, there are high-paying, lucrative, lots of jobs working specifically not on the application, but just on the back end, the database, right? So it's very common in application worlds to think about like the different pieces of a system. And this is a terrible photo in my opinion, but you can start to understand there's kind of what the client sees. Okay, so what the client sees might be a website, might be a desktop app, might be a mobile app. Okay, this is what the client sees, the client software, and what we've done in this class is we've designed what you would call the front end. The front end is what the user sees and what the user interacts with. And so in C#, that's your text box, that's your buttons, that's the colors, that's the front end. In web development, that's the website, that's the logos. Okay, that's considered front end, what the user sees. Then there's a middle tier. So there's actually 3 tiers, right? And if you can work on all 3 tiers, you're called full stack. But there's front end, there's the middle tier, which is the application logic. That's your C# logic that you're writing the login function, right? The ability for users to log in. Processing a purchase, right? Whatever the business logic is that goes into your C# code to make the code function. Okay, that's the middle tier. Okay, so front end code, website, app, what the user sees. Middle tier is a lot of functionality, what the app can do, right? Login, searches, filters, playing songs, whatever the app can do. And then there's the back-end code, which is the data, okay? The data is the most important piece, period. The data is the most important piece of any of this. And when I say any of this, I'm talking about anything computer related, the networking, the apps that we build, the servers that exist, the computers, the laptops, the screens, the monitors, the programmers, it's all replaceable compared to the data. Okay? The data is the most important piece, period. And so what we're talking about this chapter is really the first time we're talking about purely the back end. We're talking about the data being stored in a database, in some sort of storage unit that is built for corporate enterprise America that can store millions and millions of records and have, I don't know how many users and all this kind of stuff, right? So the data is the most important piece. If you don't believe me, become a database administrator and delete some important records and watch how fast you lose your job. Data is very important. And so, again, if you look at what we've been doing so far, you could say that we've been working kind of on the front end of what the user sees, and we've been working in that middle tier, which is the application logic. And this is really the first time we're going to work in the back end. And that back end, is where you store the data and where the data resides, or you would say persists. And so like right now, all of our applications are actually quite fake in the sense that as soon as you close your application, let's say you've got some customers, right? And we've all, searched for customers and updated customers. So John Smith changed his name from John to Jonathan Smith. And you update John to Jonathan in your C# application. Well, then what do? You close it and you reopen it, and it goes back to what it was before. It goes back to John. Like, your list isn't actually updated except for in a temporary sense, right? The data resets every time. The data doesn't really persist. Those changes don't persist. Okay, well, that's not going to be the case anymore. We're going to be making changes to a database, and that's where the data is going to live. So if we change the data, if we update a record, it's real, it's live, it's going to remain changed. And so for the first time, our applications are going to be a little bit more seemingly real world because of that, right? Because when we make an update, that persists. When we delete something, that persists. When we add something, that persists, right? So that's kind of cool too. What's up, Vinny?
You kind of answered my question, but
okay.
That's what SQL is, right? It's like an online server database that stores.
Yeah. So SQL stands for Structured Query Language, and it's a standard to work with databases, and so it's a language that works with databases. When I say works with databases, what am I talking about? Well, SQL can be used to create a database, create tables in a database, insert data into databases, right? Pull data out of databases. You can use SQL to make databases more efficient with these things called indexes, right? So SQL is just its own language. Now, it's a standard, and different companies have taken that standard and made what I would call different flavors of SQL. Okay, so there's one flavor of SQL called Transact SQL, T-SQL. Okay, Transact SQL is Microsoft's flavor of SQL. Like, they took the standard and they made it their own. Another big company is Oracle. And Oracle took SQL and they kind of made their changes, their syntax changes, if you will, where semicolons go, where quotes are required. And they made what is called PL SQL. So like on the surface, SQL is the standard. We're going to learn a flavor of it. We're going to learn Transact SQL, right? And for those of you who are into martial arts, it's like, okay, well, how many flavors of martial arts are there, right? Martial arts generally is like a practice, but there's a lot of different ways to practice it, right? And so that's all we're doing. We're studying one of the main ways, that Microsoft implements SQL in this flavor called Transact SQL. So, yep, SQL is a standard, and that's what we'll study. Ultimately, the database, at the end of the day, the database is just, it's kind of interesting that at the end of the day, a database is just a file. Like if you actually get onto a computer that is functioning as a database server, a database, if you boil it down and you look what it actually is a file, and with us, and I'll zoom in here. Database is a file with a .mdf extension. And so, like, you might have a customers .mdf, and this is a file that would, contain a database. So at the end of the day, like, it's ultimately stored as a file on the computer. The more customers there are, the bigger that file is. There's also a log with a LDF extension. So it could be something like customers.ldf. And these two files are essentially linked together. Like, you need to keep them together. There's the data is stored in the MDF, And then a log has all the transactions, all the updates, all the new things, all the deleted things. It's like a log of what's happened to the database. Okay, so at the end of, like, if you really boil it down, we're going to study databases and like how they are structured and what's in them and how they look and how they work and all this stuff. But at the end of the day, they're just files. And those files, if there's a lot of customers, are big files, gigabytes or terabytes in size. And there's a log as well. Well, what is a database server then? A database server is a computer with the MDF and the LDF and makes the data accessible to apps. So these files exist on a computer somewhere. That computer, by the way, databases are everywhere. Everything uses a database. Every software that we use is data driven. They're everywhere on the internet, right? You can't go anyways. A database server is just a computer. Sometimes it's a Windows computer, sometimes it's a Linux computer, whatever, with the files, and makes the data accessible to apps. And accessible with permissions and credentials and that kind of stuff. Well, how do you make it accessible? The computer makes the data accessible through software. When you install this software, I like to think of it converts your computer into a database server. Like this computer right here that's on my floor, it's just a Windows computer. Okay, it's got Windows 10 on it. Okay, it's just a computer. Okay, I can convert this computer into what's considered a database server just by putting the right software on it. Because that's really all a server is something that offers a service. Like, hey, I got a bunch of data in a database, and if you build an app, like I might let you access it and work with it, depending on the permissions. And so I got a couple questions, and I'm going to get them right quick. What software then? What is the software that converts a computer into a database server? Well, it's called Microsoft SQL Server. Yeah. So we will install Microsoft SQL Server onto you'll install it on your laptops, and I'll install it on my desktop, and it will just transform, if you will, our computer into a database server. It's just software. And if you think of a client server, really what is a client? A client is a user of a service, and a server is a provider of a service. And so it's just a relationship. Client server is just a relationship. It's a temporary relationship, right? So if I have files on my computer here and Amel accesses his computer, accesses my files, in that relationship, he is the client and I am the server. Okay? But if Amel has files on his laptop and my computer goes to access those files, then in that case, he's the server and my computer is the client. You see, it's just a relationship. So if you're accessing a service, you're the client. If you're providing the service, you're a server. Okay? What makes what we're about to do confusing? Because in that example where I'm using two different computers, it's a relationship between two computers. What makes it a little confusing in this environment is that my computer, when I'm doing this, I'm going to act as both the client and the server. Okay, so I'm going to make the database, which is, has the data, which is separate from the application. The application is the client. And so essentially what happens is that my computer will be both the client and the server. And that's how it is in development. In development, your computer can act as client and server. In production, though, typically, if you're going to have a lot of users, you don't want one computer being the client and the server. You're going to have a dedicated computer. That computer is turned on 24/7, right? It never powers down. It just stays running. It's in the data center, right? It's a, depending on the application, it's a supercomputer, right? And very high end, very expensive, and it's going to host your database. It's always going to be powered on. Like in reality, we don't want my desktop acting as a server because I power it off at night, right? And if you go to use the application at night and my database server is down, that's not real world, right? So in the real world, you never have like these, I mentioned the 3 different tiers, like you separate those out into different computers. Vinny.
Well, so that was my question earlier. Was you have like Google, and everybody has an email, and so like I assume Google has this huge like supercomputer or computers. So like, is it just always running?
It's absolutely computers. It's absolutely.
Or is it like
we'll just say thousands and thousands of computers, all across America and the world.
Mm-hmm.
Okay, so they have data centers.
Yeah.
I mean, they have data centers in the bottom of the ocean, for God's sake, if you've seen that kind of stuff.
I have not, no.
So why do they have data centers all over the world? Well, because they want email to be fast all over the world, and for that kind of fast login, fast response, they're going to have local, and I'm sure it's just like that in the gaming, right?
Yeah.
In the gaming world, you choose your server. Why do you choose your server? Because it's more local to you and you get better pings, right? It's the same way with the Google email servers.
So my other question, does that mean that like even Google uses MDF and LDF files like at its core?
So when you're talking about email servers versus database servers, absolutely, now are there other file extensions besides MDF and LDF? Yes. MDF and LDF, those are Microsoft, right? But think about this, like, and for anybody who's ever used a Mac, like on a Windows computer, on a Microsoft computer, to run a file, it's an executable, a .exe. But on a Mac, it's not the same file extension. What is an executable on a Mac?
It's just like their brand of an executor.
It's their brand. I don't even know what it is.
I know what you're talking
It's like a PDB or something. I don't know.
Yeah.
But it's not exe on a Mac. But they're both executables. See what I'm saying? So it's the same thing. Like Microsoft database files just have a different file extension, but they both do the same thing.
It's a .dmg.
DMG, thank you. Damage. Why? Like executable makes sense to me. DMG doesn't. There's a lot of things about Macs I don't understand. That's just the tip of the iceberg. Okay, client server is just a relationship, and a network is just a medium. A network is just the cables that allow our computers to communicate. Okay, a primitive network can literally be a parallel cable connected between 2 computers. The first network I ever made was a parallel cable, and I connected 2 computers together, and I played World of Warcraft on them. Like, not World of Warcraft, because that's the MMO. Warcraft, like Warcraft 1. Like the RTS, right? Warcraft? Not the MMO.
Yeah. Was it StarCraft? You played StarCraft?
I was an Age of Empires person, really.
What you talking about? Warhammer? I knew you were talking about. I thought that was Warcraft 3.
I think it might have been Warcraft 1, 2, 3. Anyways, so that's some basic terminology. At the end of the day, we're going to build an executable exe that's going to run on the client. The client will be both the front end and the middle tier. Okay, the front end being what the user sees, the middle tier being the login functionality, the methods that we write in C#, right? The classes, the objects, all that's middle tier. we'll write some C# code to query the database. All a query is a question, or like, hey, who are all the customers with purchases greater than $100? Like you're asking a question of the database, but a query does more than just request information. A query can also do all the CRUD operations. Okay, but we're basically going to use, C# logic, and at the end of the day, we're going to write what's called link to query the database. So we're going to learn SQL in about a week. We're going to crash course SQL for a week, and then we're going to crash course link for a week, which is very similar. Link is actually going to be what we use to query our database. It's very similar, and once we learn SQL, we can learn link pretty easily. Again, there's a database management system, DBMS. So Microsoft SQL Server is considered a DBMS, database management software system, database management system, DBMS. DBMS, fancy term for database software. Okay, DBMS. The other one, again, would be Oracle. There are other database management softwares called MySQL. How many people have heard of MySQL before? At least have heard of it. Oracle is another DBMS.
What is jQuery? I've heard of that one. Is that like link?
jQuery is not a DBMS. jQuery is a JavaScript library that makes web pages interactive. So it's different. There are many DBMSs. This is the one we're going to use in this class. It's Microsoft brand, everything we're doing. Microsoft C#, Microsoft SQL. We are not doing MySQL. MySQL is nice because it's lightweight and it's free. Microsoft SQL Server has a free tier, but like so many things in this world, if your software grows big enough, you're going to wind up paying for it. Okay, so we're going to use the free tier in this class. Oracle is also something you have to pay for. Okay, MySQL, I don't have a ton of experience with MySQL, and so I believe it's free. I don't know if eventually you have to pay for it, but I do believe they offer a free tier as well. Point is, these are all database management softwares that you could implement. Again, Microsoft SQL Server is our database management system. It's just software. Database is referred to as the back end. We covered that. Client. The software that we write is going to act as the client. There is a front end. Again, I'm repeating myself, what the user sees. There's a middle tier, classes and objects and methods. This is our what is called business logic. The first time I heard that, it sounded intimidating. It's the business logic. It's just the functionality. It's just the functionality of our app, what the app does. On the middle tier, there's something called a data access API. I love the term API because it's misused pretty frequently. Like, people use it when they're to sound sophisticated and they don't know what it means. Okay? So I'm gonna give my definition, and hopefully anytime you hear API from someone who's trying to sound sophisticated, you can think of it as a basic level. So what is an API at a basic level? It is a public library of code. Or maybe even have my first word incorrect. Sometimes it's not public. Sometimes public or private. More importantly, it's a library of code. What is a public API? What's a library of code? A library of code is just a bunch of pre-written methods, a bunch of pre-written classes. You know, what are we technically studying? We're studying C#, but we're studying all the classes and objects. We're studying the C# library of code. So it's basically all the pre-written code that you can use when you're studying a language. A library of code, the code that is already written to utilize in development. Right, so if you're studying Java, technically you're studying the Java API. The pre-written code that other developers made this library of code available for you to use. Okay, if you're studying C#, you're studying the C# API, right? API is just pre-written code that you can use, right? Sometimes you develop and you make that accessible publicly. You know, you develop a library of code. For example, Vinny correctly used the term API this morning. He said, hey, you know, for my final project, it would be easier if I could just use an API that already exists that provides access to data. In other words, this game that Vinny plays has a bunch of statistics. They're all recorded in a database. Someone wrote some code and made that data accessible for Vinny's application. So that Vinny's application could consume that API. You could call those methods, and those methods would return the data that's existing in a database. So what Vinny essentially said to me this morning is that, hey, there's a database server somewhere that made a public accessible data access API. And I just want to write my C# that calls, that consumes that API. And that's a very common use case of a public library of code that's out there. And you will, in your third and fourth semesters, consume public APIs. Okay? Another example of that would be eBay. Another example of that would be Twitter. Another example of that would be Facebook, Instagram. They all have public accessible code. That you want to pull your feed off of your Twitter and put it onto your website. Twitter makes methods available through their API. It says, hey, you know, just give me some certain credentials, some certain usernames, you know, give us the right credentials to access the data, and we'll let you have access to our data. I know in fourth semester right now, just as an example, they're using the eBay API. And they're getting current listings for video games. So people are reselling video games. And so their mobile apps are using the eBay API to get current listings for Smash Brothers or whatever. And so that's very useful. In the .NET world, and they're going to talk about this here, there's a data access API called ADO.NET. ADO.NET is a data access API. It is one way to have your middle tier work with database on the back end. Link is another. Data Access API. And I might have this a little bit. LINQ might be a subset of ADO, but I don't think so, because LINQ stands for Language Independent Query, and so you don't need to be in .NET. LINQ is actually, the whole purpose of LINQ is you learn one data access API that can be used in many different languages. So what's unique about ADO.NET is that it's only good for .NET. Right? LINQ is, the idea behind LINQ is that you could use it in PHP, and you can use it in C#, and you can use it in C, and you can, the idea is it's supposed to be language independent. Right? So the data access API that we're going to learn is portable, is more portable than ADO.NET, which is a good thing. So this is a library of code, if you will, a bunch of methods in the system for accessing data from our applications into the back end tier. Okay, we talked about SQL, and we'll pause right here. Okay, just resume the recording. We got everybody back. We talked about database software that you put on a computer, and I called it a database management system, DBMS. You could throw this extra letter in front of it. We'll call it an RDBMS. And R stands for Relational Database Management System. And a relational database management system is what we're going to do in this class. This is traditional way of implementing databases. And when I say traditional, I'm also meaning old. This is an old way, but just because it's old does not mean it's not prevalent. It is very prevalent. In fact, I'm going to say it's more prevalent than the alternatives. There are more relational databases than otherwise. So we're going to learn all about relational database management systems, again, because they're the dominant, they're the lion's share holder of database systems. Okay? But they are old. They've been around since, doesn't really matter, let's just call it the 70s. Maybe before. Relational database management systems have been around a long time. I mean, since the early days of computing. Like in the real early days of computing, everything was just like local file storage, like storing it on your computer. And then pretty quickly they realized that's not efficient. They got to find a better way. And that's when relational databases came around. Again, I talked about this. So when I said database management system, you know, I mentioned MySQL, Oracle database, Microsoft SQL Server. These are the big ones. There's an up-and-comer. I don't even know how to pronounce that. Postgres. I think it's called Postgres. Postgres SQL is, I believe, how you pronounce that. This is a little bit newer, but there are many others. Okay, these are all relational database management systems. That's what we will be learning. The alternative to relational, so that relational is one kind of database. The alternative is called NoSQL. On the surface, you get the idea that it's not what you're used to, because SQL is the standard. This is called NoSQL, and the data is stored very differently in NoSQL databases. So if I kind of look up a NoSQL database, MongoDB is one example. NoSQL databases, aka not only, so it's not no, but not only SQL. are non-tabular databases and store data differently than relational tables. So we're going to learn the traditional majority share system, which is relational databases, but in third semester you will learn Mongo and NoSQL. So you'll learn both, and this is the more modern approach for fast, scalable, modern applications. So just to touch on the different types of database management systems that are out there, there's basically relational, then there's NoSQL. We are studying relational databases. What does that mean? We're not studying NoSQL. This is the fun part, because this is I had a lot of questions when I first got into databases, and I think those questions kind of went unanswered, and I like teaching this because I like some of the key things that I had to learn to really understand it. When you first look at a slide like this, you say, okay, this is the first introduction to a database. What are we looking at here? Well, this kind of looks like Excel, right? And so right off the bat, when I look at a table in a database, what's the difference between a database and Excel? By the way, if I go back to that slide or the Google search on relational database management system, you'll see that built into Office 365, the software for databases is called Access. It's not called Excel. However, most people are familiar with Excel. They're not familiar with Access. So a lot of the questions that I had when I was first studying databases is well, that just looks like an Excel table to me. What's the difference? What's the difference? And so I think I can start to answer some of those questions. What's the difference between Excel table and relational databases? Okay, Excel is a spreadsheet software for end users. That's the purpose of Excel. It's meant for the end user. It's not meant for storage of data for, I'll even say, medium to large applications. You're not going to store millions of customers. You really shouldn't be, for a modern application. Because in Excel, it's not scalable. It doesn't scale well. You find out when you start storing data in spreadsheets, there's a lot of information to store. And so if you think of Amazon, right, there's customer records, there's transaction records, there's purchasing records, like past purchasing records, there's what you've searched for, what they think you might be interested. There's a lot of information. So if you, in my mind, when I'm first studying databases, I'm just imagining this huge spreadsheet of information, one spreadsheet full of all the data. Just put it all in one place. And very quickly, if you start thinking about that, you start storing all your information in one giant spreadsheet, you find out, and this is kind of like the evolution of what happened. If you start storing all of your info in one, think of a giant spreadsheet, some problems will arise. Did I spell that right? Who knows? Like, John Smith lived at 25 Rankin Avenue in St. Louis, Mo. And he bought a t-shirt, whatever. Well, then John Smith moved, and John Smith moved to 27 Rankin Avenue in St. Louis, Mo. And he bought a car. Okay. Now we've got 2 records in the database, and right away, what's the problem? Well, you don't know where John Smith lives. At one point in time, he lived here, and at another point in time, he lived there. Okay. So that's a problem. What other problems could we have? Well, you start selling, what did he search for to buy the t-shirt? You start storing all this information in one place. Let's try to think of something that, maybe there's a column for, external link. I don't know, I'm just making this up. John clicked on an external link outside of Amazon.com to come to this purchase page. So did John get referred from an external link, or did he go to Amazon.com and find this internally? So there's an external link, and that external link would be www.somesite.com. So if there was a referred link, you get the URL. But then other times, there's not. There's nullable values. And so you end up, if you're storing all this information all in one place, not only do you start getting conflicting data, but you start getting these fields that are, sometimes there's data in them, sometimes there's not. There's a lot of nullable values. Well, okay, so what about his wife? Jane Smith made a purchase. And let's say they're now living at 25 Rankin Avenue, St. Louis, Mo. She bought a pen. And she was also not referred. Okay, Jane Smith bought something. But then she returned it. She returned the pen. And so you can no longer keep this record. You got to get rid of the record, And so, well, maybe you want to keep the customer. You don't want to lose Jane Smith as a customer, but if you delete the record, well, not only am I deleting the purchase information, I'm also deleting the customer information. So that's a problem. Okay? So as it turns out, like in my mind, is store everything in one giant spreadsheet. Turns out that's very inefficient for these kinds of reasons. Okay? These are problems with the data. Okay, if you store it all in one place, problems will come up. There's a fancy term that you'll hear called data anomalies. Okay? All the phrase data anomalies means is problems with the data. Like your data's not in a good state. You got conflicting information, you got all these null values, you're deleting things, you shouldn't be deleting things. Like if you think of the CRUD operations, create, read, update, delete, you could have CRUD anomalies. Like you could have delete anomalies and update anomalies and all these kinds of things, right? Problems with the data. So they found out that instead of storing all the information in one giant spreadsheet, like you would think to do in Excel, a relational database, instead, relational databases store information in many spreadsheets, but they're not called spreadsheets, they're called tables. They're just rows and columns, just like a spreadsheet. Okay, they're just rows and columns, just like a spreadsheet, but there's some differences, and I'm going to highlight the differences. Okay, okay, they store information in many tables. Here's the deal, and they link. I'm putting this in all caps because it's important. The tables together somehow. They typically they link the tables together through the magic of what are called keys. I'll even sarcastically type in the magic of keys. You gotta learn what is a key, right? A key is a big deal in a relational database management system. So instead of one giant spreadsheet with all this information creating all these data anomalies, we're going to break up our data into many tables, maybe 10, 20, 50, 100, 1,000 tables, who knows, depending on the software, it all changes. We're going to break the tables up into smaller, and they're not going to be called spreadsheets, they're going to be called tables. And then we're going to link them together through this thing called a key. Because of this, this is what allows relational database management systems to scale, right? To scale to support large applications, large software apps. Okay, so if we think about Excel, Excel's not meant to support. Now, does that mean you can't write some application and link it into Excel and store your data in Excel? Yeah, you can do that for like a personal project, or maybe a small business has an application and you just know how to work with Excel very efficiently, and you can make macros and all this kind of front end, and you can do that. And that's definitely done. You know, end users who understand Excel, advanced users of Excel, you know, they can build small applications that are functioning using, you know, keeping track of their customers and things like that, but it's not meant for enterprise software, okay? So like if you get down to like, what is the purpose of Excel? It's for end users. What is the purpose of a relational database management system? It's for support of large applications. Does that kind of make sense? Did you guys kind of wonder that yourselves ever? Like, or do you ever think about that? Does that make sense? Like, does my mind work like yours? Not at all. That's cool.
I mean, I haven't thought about that, but I can see how you do think about that.
Like you can see the connection there.
Yeah.
You can see the connection there. So a couple more things. Couple more things here. Let me not do that. These tables have data types. Well, isn't that convenient? We just studied data types. We know about data types, integers and floats and doubles and decimals, and you know, it would be nice if the data types always matched. Like the database data types were the exact data types that we have in C#. That's just not the case. Unfortunately, SQL Server Management Studio, they don't have a string data type. They got this funny data type called nvarchar, right? It does sound like a Pokemon. The letter N, the word var, the word char.
Is it all one word?
All one word. nvarchar, and then you put max, and this is the data type.
I'm good.
And what that means is string. And if you break it down, N means we're working with Unicode. And what does Unicode mean? For every character, you got 16 bits. We know Unicode because we looked at Unicode charts to study the encoding software that we wrote, right? We know what Unicode is. It's converting things from letters into binary. Okay? var means variable length. You can have variable length number of characters. N, Unicode. Var, variable length. Char, variable number of characters. Max means you type as many characters as you want. There's no limit on the number of characters that you can type.
Can you assign a limit?
You can assign a limit by putting 100 Unicode characters. It does make sense. Once you break it down, it makes sense.
Is it like an array where, like, if you put max, it's going to like assign that amount?
It's
of
dynamic.
to it?
It's more efficient than that,
Good.
thankfully. Okay, but they have data types. So part of creating databases is giving their columns specific data types. Okay? You're going to say this column is for the user's age, and therefore we're going to store integers. This is for their first name, so we're going to store it as an nvarchar max. Okay? But maybe for some advanced Excel spreadsheets, you can have data types. I'm not familiar with that, but to me that's a difference. Like, you don't typically have data types in your columns in your Excel. Not to say that you can't assign them, but you will assign them here. There's no optional data types. Okay, your columns, again, vertically, obviously columns go up and down. Your columns have data types. Okay, so that's a big difference between a database and Excel. We could say Excel has optional data types. Database management systems have mandatory data types. Okay? So back to this, we can now understand that this is a single table. A single table. There's probably many tables. And the tables probably are linked together through some magic thing called keys. Okay, we need to undiscover what that means, these keys. Instead of calling it magic, we're gonna understand it, right? It's important to understand keys. Like, if there's one major takeaway from studying this week, like, you need to understand the keys. That's probably the most important thing that you can understand, because the keys are how these things are all linked together, right? And that allows you to break up a giant spreadsheet of information into smaller tables of information and just link them together. Okay, lot of terms here. Okay, let's go through some database terminology. Obviously, we have rows, aka records. Okay, you know what a row is. A row goes across. You could also call a row a record. To me, they both start with the letter R. That just makes sense. Row could also be called a record. A customer record would be about one customer, right? So that goes across. Then there's columns. Oh, well, I remember, when I was pretty young, like, I would always get rows and columns confused, and it wasn't until I looked at my neighbor's house and I saw the column, the pillar that held the house up, that I remembered what a column was. So if you ever get rows and columns confused, think of those pillars on homes that go vertical. There you go. You know what a column is. That's how you remember it, right? Columns, pillars, they hold up the house. The big houses, not my house, I have a small house, but people with nice homes, they have columns in front of their house. Pillars, okay? Columns have data types. The intersection of a row and column is called a field. Just kind of makes sense, I guess. Your cell of data. The individual cell is called a field. If you have a customer record, a single piece of information is a field about the customer, right? We would call it a property in C#, like the first name property. what am I? I said keys are important. So here's the most important term. One of the most important. Primary key is a column. So you would call it the primary key column that enforces a rule. That rule is that each row must have a unique value for this column that, well, you could just leave it at that. This enforces uniqueness for that record. I said a whole lot there. But it's kind of a simple concept. A primary key column is a piece of data that enforces uniqueness. So like for all of our students, what is a piece of data that would enforce uniqueness on all of our students? Like a unique piece of data about all of you. Okay, student ID, that's a great example. Student ID, now you could have 100 John Smiths, and they just all happen to live at the same address. They're all brothers. So that record of information for those John Smiths, each record's going to look really similar. If you go across that row, you know, their names, their addresses, they're going to be really similar. But there's one piece of information that has to be unique, and that's going to be each John Smith's student ID. Okay? And so every other field could match in all of those rows except the primary key column. Okay? You would say this enforces a unique constraint, meaning each record has to be unique. Each row has to be unique. A constraint is a rule on the data. Right? What is a constraint? Definition of a constraint is a rule on the data. Right? There's a rule that we're going to make up. This rule says every record must be unique. So in an individual table, boy, was I confused when I first heard this term. So let me.
Looks like a rapper name or something.
That is funny. So isn't NF a rapper?
Yeah.
Yes.
So now we got 3NF, which is 300 NF, 3 times 3. You're 3 times better than NF. No, you're not with me here. Okay, here we go. Let's get back to third normal form. Boy, what a funny word, normalization. I would be sitting in meetings and people would talk about databases and they're talking about normalized databases. And I'm going, what are you talking about? What is normalized databases? And it turns out, I didn't at that time really understand databases very well because it's a pretty normal thing to understand what normalization is. Normalization is a process for storing data in a standard format. So 3NF stands for third normal form. You get to what's called third normal form by following a process. That process is just, step 1, do this. Step 2, do this. Step 3, do this. Step 4, do this. Step 5. And then let's just say you do these 10 things, and now your data is stored in a standardized way. That's called 3NF, third normal form. Okay? So there are higher levels. There's like first normal form, second normal form, third normal form. fourth normal form, fifth normal form, sixth normal form, okay? All that means is that you're following more steps to get your data stored more and more efficiently, okay? And at some point, I don't know where they stop. The standard, though, is to follow the steps up to third normal form, okay? Part of the process, step one of the process of the of the normalization. Step one of the normalization process is to put a primary key on every table. Pretty simple. So you know that we're storing our data in tables. And you know that each table should have a primary key. That primary key enforces a unique constraint, meaning each record must be unique. No two records can match. So if we've got 100 tables, all of our 100 tables have primary keys, and therefore all of the records must match.
So it's kind of like something that when you're entering information into a database, you have a combination of something that's running that the user can't see, and then the fields that they fill out. So like you have
Absolutely. Absolutely. So just because your customer table has a customer ID, you might not make that accessible to them. So they have some fields that they can see about themselves, but like, I don't know my customer ID on Amazon, right? I'm just Evan Gudmestead to Amazon. You know, at least to me, that's what I see, but I don't know my customer ID. Right.
Discord, you have like your four numbers or something on Discord whenever you're adding.
So are those four numbers considered your primary key? Is that?
Okay, so now we're talking about Discord and four numbers on Discord. I don't know what that is.
There could be 1,000 Vincents, but there's only one Vincent number, whatever my number is.
Sure,
2, 3, 9,
that's
7.
it. Could be. It could very well be your primary key. Mm-hmm. The point is it enforces uniqueness. Now, in the real world, we watched a video on this last semester. There's a process, like what we're going to do in this class is to enforce uniqueness on our rows. We're going to set up auto-incrementing counters. They're just going to be numbers. So our first customer will be customer 1. Our next customer will be customer 2. Our next customer will be customer 3. And so these auto-incrementing counters will start at 1, increment by 1, and that will enforce uniqueness. We'll have no two matching customers. And so that's what we'll do in this classroom. Turns out that's not very secure, okay? That you can predict customer IDs very easily that way. So there's a process called a SALT, S-A-L-T, and that'll take like an auto-implemented random number and then add some crazy hash to it to make it a unique value. So there's an encryption on your primary key value. So it's not predictable, right? Because then your database is predictable and less secure.
So I guess you kind of answered it a little bit, but say you have on Amazon, you search up basketballs.
Yep.
And you're gonna have more than one
Yep.
basketball that's the exact same basketball.
Okay.
That shows up.
Yep.
And how are they gonna be unique to one another?
Well, you mean you have the same basketball, but there's different sellers, right?
Yeah.
So probably, and different sellers are the same, and I might sell the same basketball that you're selling, but we're selling them at different prices, right? So you could store the basketball once, the customer or the providers twice. You know, I don't know if that's the most efficient method because those basketballs, you might have to store them twice because we have different prices.
I imagine that the sellers also probably have a unique ID or something as well to differentiate.
The basketballs will have unique IDs. The sellers will have unique IDs. Every table will have a unique ID. So I guess your question is do we store the basketball once or do we store it many times? Is that your question?
And how do you, I guess kind of it's more of a broader question. there gonna be a scenario where there's not uniqueness between two things that you have to like put in the database?
Where there's not uniqueness between two things that you have to put in the database. I'm trying to follow.
So like, is there
The same thing twice.
Yeah.
The same thing twice. Like in your example, the same basketball, but different sellers, right?
Yeah.
Probably, that's a good question. That's a great question.
Actually, would that be kind of like a generic? So you just say basketball, but you don't include a brand name. So you just have a generic ID that can be applied to multiple things?
Maybe. I'm thinking in that case, like if you have two different sellers, you're probably having two different basketballs. Like even though they're the same physical basketball, they're coming from different sellers but different prices. So that price might, is going to have to differentiate them. So even though physically they're the same thing, I'm thinking through the software you're going to have to list them as two different things, which seems a little bit redundant. But you could do that. That wouldn't be hard. Yeah.
With the way that you look at certain products on Amazon, where it is the same thing, and you have the option to go through multiple sellers, isn't that kind of like with the mutators, the getters and headers that we've gone through?
And that's what we will be doing, is tying all that in together into one. Yeah. So I could see it going either way, Ryan. I really could. I could see you storing that information redundantly. That's not the most efficient way of storing it. Or I could see it being entered as two different basketballs. Probably, I don't know what the answer is there. I imagine throughout all of time and all these systems, it's been done both ways. It could be done both ways. Yeah.
So I think as long as you have, as long as each, user of, let's say, a website, let's say their primary key is, their email address. Well,
Yep.
Even if it's the same, domain, well, it's still a different. Well, no, I'm sorry. If it's a different domain, it's still a different email address, even if it's like the same core. As long as each user on the website has a different email address. Well, you could just have this user dot sell list, like things they're selling,
Yeah.
and dot basketball. So even if they're selling the same thing, it's from two different users. Therefore, it'll be able to differentiate between the
difference. Yeah, I could definitely see. I could see it going either way. And you're right. Yeah, I mean, it would be unique in the sense it would be coming from different sellers. Okay, so let's make sure we cover all these terms. We know relational databases. What does that mean? We just have tables that are related through their keys. Many tables that are linked together, by what I mean related through their keys. Tables have rows and records, fields and columns. They have primary keys that enforce uniqueness. Unique key constraints. Again, a constraint is just a rule on the data. There's also something called an index, which is just like you flip to the back of your index in your book, and you can look things up faster by going through an index. Tables have these things called indexes that help retrieve data fast. Right? So this is going to be a way to look up information fast in a table through what's called an index. We talked about one very important concept, which is a primary key. Now we have to talk about the sister of the primary key. Okay? Related to the primary key is the brother. The sister is this thing called a foreign key. Let's set this up. We have a customer table, customer ID of 1, John Smith, customer table. This will be me. Customer 3, whatever. Customer has purchases. Customer ID is the primary key. Okay, we're going to set this ID up to the primary key. It enforces uniqueness on this table. Customer ID is the primary key. Purchase table. We're purchase number 1. We'll call it purchase ID. I'm going to leave this second one right here. I'll explain that in a minute. This is going to be also this first one. Let me label this. Purchase ID is our first. Customer ID is the second. Product name is the third. So these are the columns for this data. Customer ID, lowercase d, again, there's going to be some conventions here. Customer ID, so purchase ID. Purchase ID is what? It's the first column, but we're also going to call this the primary key. This first column is going to enforce uniqueness on the table. Purchase ID is the primary key. Customer ID is the foreign key that links to the customer ID column in the customer table.
It's a lot.
What is this? Okay, again, this second column right here, this number 1. In this other table, this customer ID is going to be referred to as a foreign key. It's going to link to this customer ID column in the customer table. What does that linking do for us? Why is this column? Now I'll do a couple more entries here. And I'll say, okay, purchase ID of 2, the second purchase, has a customer number of 1. John Smith also bought a t-shirt. Purchase number 3, customer number 2, Evan Gudmestead bought a pen. Purchase number 4, Evan Gudmestead bought a cup. Purchase number 5, John Smith purchased a router. So this column right here is our customer ID, which links back to the customer table. Customer number 1 is John Smith. Customer number 2 is Evan Gudmestead. Sam Long's a customer, but he has no purchases. You see it? That number represents data from another table. Yeah.
It's almost like inheritance, kind of. But my question is, customer ID. It's a primary key in one table, but then it's a foreign key in the other. So is it still considered a primary key even in the purchase table?
No. Nope. It's just called foreign key because it links back to a primary key.
Okay.
It links back to a primary key. Now let me ask you this. We talk about rules on the data, right? Rules on the data. Primary key enforces uniqueness. What does a foreign key enforce? Foreign key constraints. Foreign key constraints enforce the data first exist as a primary key value before it can exist as a foreign key value. Well, I think that's just going to make sense if you stop and think about it. Let's say purchase number 6, customer number 4 purchased a mouse. What? Customer number 4? Who's customer number 4? There is no customer 4. You can't have a customer 4 here until they exist here first in the customer table. You with me?
So it's like validation.
Validation. In order for this foreign key to exist in this table, the value has to first exist as a primary key in this table. You can't have a purchase without a customer. You can't have a purchase without a customer.
You can't have a foreign key without a
You can't have a foreign key value without the primary key value first.
What you call like SQL injection.
SQL injection, you're talking about writing queries against a database in a because like from a website, like you're not supposed to be writing SQL queries like give me your first name, and in the first name I'm going to delete star.star. That's a SQL injection where you're trying to run SQL code against a database before. Maliciously, maybe, right? But that's a big deal. All this that we've covered so far, just understanding relational databases. Relational databases just means you got a bunch of tables. All the tables are linked together through primary and foreign keys. So there can't be a customer number 4 in a purchase table before there's a customer number 4 in a customer table, right? It also says this, like because that purchase was not valid. Foreign keys also say this. Now you would agree that John Smith has a couple of purchases, right? John Smith has purchased a basketball, and John Smith has purchased a T-shirt and a router. Okay, so John Smith has 3 purchases. Well, foreign keys also say I cannot delete John Smith as a customer. Why?
Because foreign key is storing a value from the primary key.
That's right.
So if you delete the primary key, there's you're deleting
You're right.
data.
Yeah. So you cannot delete John Smith because John Smith has purchases. In order to delete John Smith, if you wanted to delete John Smith, you would first have to delete all of his purchases, and then you could delete John Smith. Okay, so that's called a cascading delete. You would have to delete the customer and all the customer purchases. Okay, so I guess it just says it goes both ways, right? You can't have a purchase without a customer, and you can't delete a customer that has purchases. Yeah.
So does that mean let's take Amazon for example. If I delete my Amazon account, does that mean that all my transaction history and everything along?
So in the real world, what we're talking about is deleting. Amazon's not going to delete your data.
There's logs.
They just keep it in their logs, and what they're going to do is they're going to archive it, because in reality, data storage is so cheap, so cheap. They're not really going to be deleting. They're going to be archiving data versus deleting data. So you can disable your account, right? But you're not really going to be running a delete operation on a database, or inactivate it, or whatever you want to call it.
Why do they archive it? Do they think someone will be coming back? Or
What if he comes back? He doesn't. Yeah, that's right. If he comes back, why not have all of his? He purchased all these Pokemon cards. Let's sell him some more Pokemon cards.
is that several group, do they also think in the future there might be a piece of that data that might be
Useful.
useful?
That's exactly what I'm saying. By the way, you know how I said data is the most important thing? I'll go back to this. Did you know, somewhere around 10 years ago, I don't know exactly the year, somewhere around 10 years ago, the world has valuable resources like gold and iron and oil. Thank you, oil. Forever, up until about 10 years ago, oil was the world's most valuable commodity, right? So the most valuable commodity historically has been oil for a long time because it helps us, not only for our gas prices, but all the plastics that can be made out of it. I don't even know all the different uses of oil, but there's a lot of them. That changed 10 years ago. You now know what's the world's most valuable commodity.
Data.
It's data. Yeah. Data is the world's most valuable commodity.
Well, it's, like Google AdSense, like, websites that make money just from people looking at ads. Like, Google sells that data to other companies.
Absolutely.
For millions of dollars.
Absolutely.
So it's like,
Huge market. So if I look at this kind of tells the same story. There's two related tables. There's an invoices and invoice line items. You notice here there's an invoice ID column. And so this is the invoice table. And you can see that invoice ID is probably going to be what? Is that going to be a primary key or foreign key in this table? So this is the invoice table. Invoice ID, if you had to guess, would that be a primary or foreign key?
Primary.
Primary key, correct. Invoice line item has both an invoice ID and a customer ID. In this table, invoice ID, this would be a foreign key. It's actually kind of an interesting case because customer ID would come from the customer table. So what you might have in this table, these two columns are both foreign keys. They come together to make uniqueness. In combination, the invoice ID and the customer ID must always be unique when combined together. So that's a combined or a compound primary key. These two columns together become the primary key. Right? Individually, they're both foreign keys, but when you combine them, compound them, whatever you want to call it, that's going to enforce uniqueness. So you can have two columns that together become the primary key, but individually they're foreign keys. You see this keys concept become very important. And we're not going to be doing, we will not be doing just, for our demonstrations in getting back to C# world, for your final projects, we don't even need multiple tables. If you have multiple tables, that's great, that's optional. But the requirement for the final project is one table. Okay? If you want to start having primary keys and foreign keys, keep in mind that those rules compound the difficulty. A column that identifies a related row in another table is called a foreign key. I think you guys understand that now, at least if you've been paying attention, following along. I've been seeing some head nods. Yes, that should make sense. This bullet is just worth reading, and then, I'm just going to read this one out loud. Tables can have relationships between them. As we demonstrated, that's just between their keys. You can set up rules on the data, further rules on the data, dependent on these relationships. One's called one-to-many. In other words, a customer can have many purchases. So one customer, many purchases. So between those two tables, one customer ID can exist many times as a foreign key. One-to-one relationship. One customer can have one beneficiary. I'm just stretching here. When you have investments, you have beneficiaries. So one customer can have one beneficiary, 1-to-1. In other words, one customer cannot have many beneficiaries. You have one beneficiary, okay, in this investment world. And so what does that really do? That just sets up a rule on the data. These relationships are kind of confusing, but because what are they really saying? All they're really doing is enforcing rules on the data, much like a constraint. Many-to-many students, many-to-many relationship. These are actually, many-to-manys are not, if you get to third normal form, check this out. Remember, normalization is a process. One of the steps in the process is to have every table with a primary key. Another step in the process is to link all your tables together through primary and foreign key relationships. To get to third normal form, you also eliminate many-to-many relationships. Many-to-many relationships are not considered good form. I don't know. Many students can take many classes, and many classes can have many students. It's not considered good form to set this up. So there's a way to break up many-to-many relationships. It's not considered good form to have many-to-manys. So again, these relationships are dictated in your diagrams that kind of helps you set up rules on the database tables.
What about like a one-to-many? Oh, what you talked about.
Yep, one-to-many, one-to-one, and many-to-many. Many-to-many considered bad. Okay, you can create databases through GUIs. We will do this. We will create databases through SQL Server. It's called Server Explorer. This is actually in Visual Studio. So there's a tab called Server Explorer. You've probably never opened this tab, or maybe if you're digging around, you've seen it. But we will we'll tinker with this. We'll create our own tables. We'll create keys. We'll create, columns with data types and primary and foreign keys and all this kind of stuff. These are our data types. Remember nvarchar? That's for our strings. Date and time, decimal, numeric, float. Remember, floats are also called real numbers, right? Like in your math class, they're called real numbers. There's an int. There's also a big int for really large, obviously. What are important about data types? They all have ranges of acceptable values, right? So int is got a different range than big int. Money is for you guys. Small money is for me. Haha. And this is what a database diagram looks like, right? They've got symbols on them, like if you look at the products table, first off, convention, they're plural because each table holds multiple records. So it's not a single customer table, it's a customers table, right? The customers table has a primary key column of customer ID.
And what's the UML?
It does. It's just boxes and lines between the boxes. The one-to-many, the one represented by the key, the many represented by the infinity symbol. Like, what is that? That's the infinity symbol, right? Yeah, the little 8 little thing. So that's representing relationships. Again, rules on the data. So you could say that products has a product code, primary ID. Invoices has an invoice ID, primary key. Invoice line item has an invoice ID, product code. These are both foreign keys that compound together for that table's primary key. Right? These little tables out here, order options is interesting. Order options is an orphaned table, right? It's a table with no link to the other tables. That's not considered good form, right? Third normal form. Ideally, in the real world, every organization follows this normalization process and gets all the tables linked together with keys and is really nice and clean. Okay? However, do you think that's how it works? Probably not. in coding, we hack things together until we just get it to work. And so when we hack databases together, you throw databases together, you get all these orphan tables, and you're missing keys. It's sloppy. You just get it to work. And so, I've had graduates go out and they say, oh boy, when we learned, primary keys and foreign keys and everything was linked together and the data was nice and clean and organized and it just made sense and it flowed together. I thought everything would be like that. And then I get out into the real world and it's just like a throw up of information and tables and nothing's linked together. And there's all these data anomalies, all these problems with data because we didn't follow this process to get the data in a good state, right? This normalization process. So we've got thousands of tables and it's just a disaster. It's just a nightmare.
What's that channel called?
So we're just back from break, and on break I've played 5 minutes of YouTube. The YouTuber's Ben Sullins, and why I pulled Ben Sullins up is relevant to where I wanted to take the lecture briefly, because what Ben Sullins did in his career before he was a YouTuber was he was a data scientist. Maybe you're familiar with the term data scientist. Just Google search it real quick. Data scientists are big data wranglers, gathering and analyzing large sets of structured data and unstructured data. A data scientist role combines computer science, what we're learning, statistics, and mathematics. They analyze, process, and model data, then interpret the results to create actionable plans for companies and their organizations. I think this is an intersection of all things that I love. Like for me, this might have been a career that I missed out on. Combining computer science, statistics, and math all in one place. Like this excites me. And what do you do with this? You got all this data out there. Arguably, there's more data than we know what to do with. You could describe it as a sea of information. There's a sea of information. Every time you purchase something, every time you scan your customer loyalty badge, every time you walk in a door, every time, all this information is logged in databases all across the world and across the internet. There's more data than we know what to do with. Data scientists take that information out and they make it usable, and they say things like, there was a blog that I followed one time, and they found, and I always thought this was hilarious, and so I remembered it. They found when a male between the ages of 30 and 40 walked into Target and purchased diapers, that there was a 69% chance, 70% chance, 80% chance, I forget, whatever it was. There was a high percentage of chance that when he bought diapers, they also bought beer. And so what did Target do for some period of time? They put beer by the diapers. And I thought that was kind of funny. At least maybe they did, maybe they didn't, but it was a marketing strategy. Why? Because they wanted to make it easy for the customer that bought diapers to also buy beer. Right? So data scientists can analyze all the purchasing habits of consumers and then tell their bosses things that they could do to sell more widgets, to sell more product. And so data science, like, honestly, is awesome. Why is Ben Sullins relevant? Well, he's an awesome data scientist. I followed his YouTube channel in the early days where he would teach you about tools to model data, to pull out data of databases and make pretty graphs. And, there's different softwares out there that can help you do this. And that's originally what his YouTube channel was. It's morphed over time, and now he's like a EV kind of solar Tesla Hummer EV, I would say I guess that's a small YouTuber. I don't know, Ben, if he ever, Anyways, I listen to his stuff. He's got a podcast. I find him interesting. Super smart. Yep.
Something that's pretty cool about like data scientists too is that it expands to any field. So not only could it beef, you could look at a chart or a graph for like a grocery store. You could look at, you're really into chess. These data scientists that analyze chess and like put these numbers into graphs, and it's like it goes into everything.
Everything.
Yeah.
Everything in our world.
Mm-hmm.
And really, it's because of these fields. If you go back 100 years ago, companies like Walmart didn't exist. Why? Well, if they did exist, there was only one or two stores. Because managers were making decisions based on their feelings and their instincts and their guts and where they think it would work. They weren't making information based on data. They weren't making decisions based on data, if I said that incorrectly. They weren't making decisions. Now, data scientists analyze a bunch of data and put pretty 5 bullet points on a PowerPoint so that managers can make easy decisions.
I think what helped Walmart stand out is once they started analyzing data and realizing how people would walk through the stores, they figured out how to lay it out, pile-wise, and then people would come in.
They learned how to optimize their floor layout to sell the most stuff from China that they sell, right?
Like milk or dairy in the back, so you could see it all the way down the main aisle. Like
Yeah.
Passing 60 aisles on the way there, and inevitably see something else you may need or whatever.
Yeah. Why do I transition it back to the PowerPoint? Because that's what the select statement does at a very basic level. Select retrieves information out of a database. This is our first SQL command. The first SQL command that we're going to learn is called the select command. It is the most commonly used SQL statement. It is used 90% of the time that SQL commands are run. 90% of the time is select. Why? Because you're just retrieving information out of the database to then put it in pretty charts and in bullet points on a PowerPoint, so that managers can make informed decisions based on data, not based on their gut feelings, which will help companies grow to be the mega giant Amazons and Walmarts and Targets. The first keyword is select. You select various columns. By the way, these are what your labs are. Your labs are just learning this, right? You're selecting various columns from a specific table where certain conditions exist, and then you order the data, sort it, if you will, order by, sort it by this particular column, descending, so on and so forth. So this is a select command. It is used to retrieve information out of a database. It's the most common SQL command. Data scientists in the select commands are BFFs. Right, here's an example. We're selecting 2 columns out of a customer's table where the customers live in Washington, WA, yeah, Washington. State abbreviations, am I right? Yep. Ordering by the customer name. Alphabetical order by the customer name. Right, so what you get here is you got a customer's table with maybe 10 columns, but you get a resulting table, right? What you look at when you select is a result set of data. Okay? You're not modifying data in the table. You're not changing anything about the data in the table. You're just looking at a result table. Right? You're just looking at a subset of the data, organized in a certain manner. Okay? So that's important to understand. When you query a table and you pull data out of it, you're not modifying that data. The data's still there. You're just looking at a result set. Here's another example. Select everything, select star from the customer's table. Okay, you're still looking at a result set. This particular result set is basically everything. But you might say, hey, wait a minute, didn't you say we have multiple tables? How can we query multiple tables at a time and get them into one result set? Like I want to take 2 tables worth of information and get them into one result set. And the answer is with this keyword join. You join tables back together. So when you store the data, you separate the data out into multiple tables. And then when you query the data, you bring it back together into one place. So you join them back together. Again, we will be doing joins in our lab. So you will be familiar with joins. Here you can see we're selecting multiple columns from multiple tables where this particular condition exists, where the customer invoice ID is line 46, where the invoice line items invoice ID. But big level, big scope here to keep it kind of high level. We're selecting columns from multiple tables where a certain condition exists. Sometimes if you run a query and this table is called invoice line items. And so here you'd have to type invoice line items, that's the table, dot column, table dot column, table dot column, table dot column, table dot column. That's a long table name to type over and over and over, so you can give it an alias. So okay, from now on, call this table LI and call this table products called products P. So it's just an alias for the tables. That way you don't have to type it out like you do here. See this? Invoice line items, products, invoice line items, invoice line items. Right? You're just giving them aliases to shorten your query. Again, we'll work with joins. Other commands that are less common are the insert. You might imagine in the CRUD operations, create is when you're inserting new data, like you're adding new data to a table, right? You're inserting a new record, if you will. You say insert into the table name and then the values. And so this says insert into the products table, specifically these 4 columns, these 4 values. So this is inserting a new record of information. When information is in the table, you might want to update a customer. So the customer name changes, right? You might want to update a customer. In this case, we're updating a products table, and we're modifying the unit price to $54 where the product code is MySQL. Maybe this is a book, a MySQL book, and we're changing the price to $54. It was $50, now it's $54. Inflation is high. And again, the most dangerous command of them all is the delete statement. Proceed with caution. You probably don't want to do this. That is the end of the lecture.